Now we are going to see the second application of dimensional analysis. What is the second application of dimensional analysis? With the help of dimensional analysis, we are able to check the dimensional correctness of the given physical equation. One physics equation will be given. We have to check it up whether the equation is dimensionally correct or not. Let's take one equation. Plenty of equations are there. I am going to take this equation V is equal to U plus AT. This is one of the equations of motion. Now, though we are often using this equation, we don't know whether it is dimensionally correct or not. So for that purpose, we have to check. Are you clear? Now, let's write the dimensions of the following quantities. What is V? Final velocity. Its dimension is Lt power of minus 1. U is nothing but initial velocity. Its dimension also can be written as Lt power of minus 1. What is A? Acceleration. The dimension of acceleration is Lt power of minus 2. What is T? Time. Its dimension is T. So now we know all the dimensions of all the quantities. Now we have to substitute all the formula, all the dimensions in the formula. Substitute here. Instead of V, substitute here. Lt power of minus 1, which is equal to, instead of U, substitute Lt power of minus 1 plus, instead of A, Lt power of minus 2, instead of time, substitute T. So all the dimensions of all the quantities are substituted in LHS as well as in the RHS side. You should try to simplify it. Here, no need to change in LHS. Write the dimension of U as it is. Here L is there, here T power of plus 1 is there. If both are added, you will get Lt power of minus 1. Are you clear? The most important thing is later don't add both as you are doing in the case of algebra. Okay. In the case of algebra, you will add both the two. If two factors are similar, what you will do? You will add it. If x plus x is given, you will write 2x. Like that, don't write. Okay. You leave as it is. Now, we have to follow one principle called principle of homogeneity. What is this? Principle of homogeneity. So here you have to mention here according to the principle of homogeneity. You have to write like this. Homogeneity. So that principle must be applied here. What that principle of homogeneity says? We have to check whether all the factors on LHS side and RHS side, whether all are having same dimension or not. So as per principle of homogeneity, you have to write like this. The dimension of LHS quantities and RHS quantities are same. This sentence must be written according to the principle of homogeneity. The dimension of LHS quantities and RHS quantities are same. Look at that. Here V is there. Its dimensional formula is Lt inverse. Look at the dimension of U, Lt inverse. Look at this entire factor. Take the entire factor and find out what is the dimension of this factor, Lt inverse. So Lt inverse, Lt inverse, Lt inverse, all are having same dimensions. Therefore, finally we have to write the conclusion. So as per principle of homogeneity, since all are having same dimensions, we have to say that the given equation is dimensionally correct. You have to say like this. this equation is dimensionally correct. This is a conclusion. As per dimensional analysis, this given equation is dimensionally correct. So this kind of conclusion must be written at the end. So this is the method called, what is this? Checking the equation by using dimensional analysis. So we have checked up whether the equation is correct or not by using dimensional analysis. Now we are going to do the problem number 1.14, which is already solved in the textbook. I would like to teach it again. Okay, you are asked to check whether the given equation is dimensionally correct or not. What is given? You are asked to check whether half mv square is equal to mgh. First I will write the equation. Half mv square is equal to, this kind of problems will be asked in the examination. So this kind of equation is given. You have to check whether this one is dimensionally correct or not. This is the expression of kinetic energy. This is the expression of potential energy. Often we are using this equation, but we don't know whether both are having same dimension or not. If both are having same dimension, definitely the given equation will be correct. Okay, dimensionally correct. So let's substitute the dimensions of the factors. This is nothing but mass. The mass dimension is m, capital M. Dimension of velocity is Lt power of minus 1, that must be squared. The dimension of mass is m. Dimension of acceleration due to gravity is Lt power of minus 2. Dimension of height is nothing but it's a kind of length. So its dimension also L. Are you clear? Now you have to try to simplify this. As we have seen earlier, this half has no dimension. Very important point. That half, it does not have any dimension. It's a number. Now you try to simplify this. M, this one must be squared. L square, and then minus 1 into 2, minus 2. So this is the dimension of LHS factor. Are you clear? Let's see the RHS factor. M can be written, here one L is there, here one L is there. This 2 can be multiplied and it can be written as T square, L square. And what is the remaining factor? T power of minus 2. So this is the dimension of RHS. So you have to write like this. According to principle of, patience is required to learn anything. According to the principle of homogeneity. Homo means same. Okay. Principle of homogeneity. The dimensions of LHS and RHS factors are same. Isn't it? Half mv square dimension is ml square t power of minus 2. mgh is another factor whose dimension also ml square t power of minus 2. Therefore, the given equation is dimensionally correct. So this kind of conclusion must be given, only then you will get full mark. Okay, thank you. Now again I am going to do one more problem to learn the concept of dimensional correctness of a given physical equation. So I will do one more problem, only then the concept will become very thorough in your mind. I will write another equation. S is equal to ut plus half at square. This is another equation of motion. Okay. Now we are going to check it up whether the equation is dimensionally correct or not. First you should know what is S. S is nothing but displacement. Its dimension is L. What is the dimension of U? Initial velocity is nothing but U. Its dimension is Lt power of minus 1. T, time, its dimension is t. What is the dimension of A? A dimension is acceleration, Lt power of minus 2. And most important thing is that half is a number. That half number, it has no dimension. That must be mentioned here. Are you clear? That half has no dimension. That should be mentioned here. So let's substitute the dimensions of individual quantities here. So dimension of S is L. Dimension of U is Lt inverse. Dimension of T is T. Everything must be written in square bracket, don't forget. Here half has no dimension. Dimension of A is Lt power of minus 2. What is the dimension of T? Dimension of T is T, but that must be squared. So write it in proper form. So everything is written. So here we have to mention that this one has no dimension. Here you have to write it has no dimension. Since it is constant, it does not have any dimension. Now you try to simplify this. As it is, you write L. Look at that. Here t power of minus 1 is there. Here t power of plus 1 is there. Both of them will get cancelled. Therefore, the remaining factor is L. Again, you do not write this one. Here t power of minus 2 is there. Here t power of plus 2 is there. After cancellation, again that one will become L. As we have done in the previous problem, we have to use the principle called, what is this? Principle of homogeneity. You have to check it up. Principle of homogeneity. This principle must be applied here. What principle of homogeneity says? We have to check whether the dimensions of LHS quantities and RHS quantities are same or not. That we have to find out. So as per principle of homogeneity, all dimensions are same. So look at the dimension of S. Dimension of S is L. The dimension of UT is L. Dimension of half AT square is also L. Therefore, LHS dimension and RHS dimensions are same. Don't add both. Very important step. Okay. So we can say that this given equation is dimensionally correct. We have to write like this. This given equation is dimensionally correct. How do I say that this given equation is dimensionally correct? Because all the dimensions must be same. If any variations in the dimension, the given equation, it won't be correct. In this case, as per principle of homogeneity, the factors of LHS side, the factors of RHS side, all are having same dimension L. That's why this is called as dimensional correctness. Okay. Thank you.